sklearn, feature selection, generic univariate select. Description. Generic univariate select is a method transformer for feature selection that applies a univariate feature selection to each feature. It takes a score function and a strategy, e.g., percentile, k-best, to select the best features based on the score. Inputs. Scorefink. This is a callable function that evaluates the univariate feature selection. It should take two arguments, the training data x and the target variable y, and return a tuple of two arrays, the scores and the p-values. Examples of score functions include fclassif for classification tasks and fregression for regression tasks. Param. This is a parameter controlling the selection strategy. It can be a dictionary with parameters for the specific selection strategy or a single parameter. Value. Mode. The mode of the feature selection. There are two modes, percentile and k-best. Percentile. This mode selects features based on the percentile of the scores. It takes a parameter called percentile that specifies the percentile to use. K-best. This mode selects the top k features based on the scores. It takes a parameter called k that specifies the number of features to select. Outputs. Transform X new. The transformed feature matrix where only the selected features are retained. Selected features. A list of the indices of the features that were selected. Steps. 1. Fit the estimator using the input data and target variable. 2. Calculate the scores and p-values for each feature using the specified score function. 3. Apply the selection strategy to the scores to determine the features to keep. 4. Return the transformed feature matrix where only the selected features are retained. Metrics. F-score, a common metric for evaluating feature selection. Accuracy, the percentage of correctly classified instances. Visualization plots. Feature importance plot. This plot shows the importance of each feature based on the scores. Correlation matrix. This plot visualizes the correlations between features, helping identify features that may be redundant. Fine-tune parameters. Percentile. The percentile of features to select using the percentile mode. K. The number of features to select using the k-best mode. Uncertainty methods. Bootstrap resampling, repeatedly sampling with replacement from the data and evaluating feature importance. Cross-validation, splitting the data into folds, training the model on one fold and evaluating on another, and calculating feature importance for each fold. Challenges and fixes. Challenge 1. Overfitting. The model may be overfitting to the training data, leading to poor performance on unseen data. Sample use case, selecting features based on a small training set with high variance in feature scores. Fixes to challenge 1. Use cross-validation to evaluate the model's performance on unseen data. Use a regularization technique, such as L1 or L2 regularization, to prevent overfitting. Increase the size of the training data. Challenge 2. Multicollinearity. When features are highly correlated, it can be difficult to determine which features are most important. Sample use case, selecting features in a dataset where multiple features are highly correlated with each other. Fixes to challenge 2. Use feature selection techniques that are robust to multicollinearity, such as lasso regularization. Perform principal component analysis (PCA) to reduce the dimensionality of the data. Carefully consider the domain knowledge and select features based on their relevance to the task.